Welcome everyone to this workshop on multi-assay experiment by Marcel Ramos. Just for the organization, so we think we will take the questions in the feed, so not in the Q&A, so in that way they can also be answered like in the same feed. If you have questions, you can also raise your hand, and then we have the possibility to actually give the microphone to one person at a time. Yeah, please feel free to ask questions during the workshop, and we will bring them to the speaker. And with that, I will just leave the word to Marcel.
Thanks, Charlotte. So welcome everyone, and thank you for coming to our multi-assay workshop. I'm Marcel Ramos. I work at the Waldron Lab and in Bioconductor, and I've been working on multi-assay experiment for quite a number of years now, and we wanted this piece of software to work with for the use cases that our collaborators needed it for, and it essentially integrates several different genomic assays into one data class or object to make it easier for people to use the data set and divide the data set with a simple number of operations. So the slides for this workshop are here in this tiny URL location. It's the same name as the workshop, multi-assay workshop. And we have a package down website built along with the workshop, and if you want to launch the workshop instance, we'll be going through some tutorials for this workshop, and if you want to run those at the same time, you can go to this website. I think many of you are familiar with the workshop link here. So the overview of this workshop is to give you an idea of what packages we use to not only represent the data, but to obtain TCGA data or cBioPortal data. And I'll also introduce you to a package that is useful for manipulating specifically TCGA data. And this package is called TCGA Utils. So by the end of this workshop, we'll be able to at least generate or create our own multi-assay experiment from scratch. And I've also provided a tutorial for using cBioPortal data, which is a relatively new package in our ecosystem here that allows you to access the cBioPortal genomics portal data from their website. So it's not on Experiment Hub, but you're downloading it from their directly from their website through an API. So this is good because we can programmatically access the data rather than using their web tools, which may not be the most streamlined process for analyzing and obtaining the data. And then we'll look at some subsetting, some operations to work with the multi-assay experiment data structure. Okay, so if you were able to spin up your instance from the containers that Sean gracefully provided to the workshop, to the participants of the conference, you'll see that we have this multi-assay workshop folder in our container. So what I want you to do is to go into the inst folder here, and there should be a tutorials folder inside that inst folder, and you click on that and go into the multi-assay experiment portion. But first, let me ask, how many people have used MultiAssayExperiment before, or are familiar with it in some way? Okay, that's good. So most of us haven't used MultiAssayExperiment, and this is a good opportunity to get familiar with the data class. So we'll go into this INS tutorials MultiAssayExperiment folder in our container and open up the exercise _ multi-assay RMD file. So once you have that opened up, as on my screen, you can click on this Run Document button here to launch a interactive Shiny app. So it does take a little bit of time to spin this up, but and make sure you're allowing pop-ups on your browser in case you need to get this window to pop up. So here is our interactive tutorial for learning how to use a MultiAssayExperiment object. So, and if you're interested in the source code for this multi-assay workshop and you want to reuse the templates that I have for creating this interactive tutorial, you can go to this link, the github.com/WaldronLab multi-assay workshop link. So what we want to do is learn how to obtain the data that we need from MultiAssayExperiment after we've created one. So we can click on this continue button and we'll get a small graphic of what the MultiAssayExperiment data structure looks like. And what we have here, we have a number of assays that we call experiments in the MultiAssayExperiment, and they can be of any size. So you can have assays that have several number of samples per participant, and you can have any number of features in each of those assays. And what we, so that's the actual data collected by the platform of interest. And the other section that we have here at the top right is the call data, which annotates the patients in your data. So you can have variables such as demographic variables or clinically associated variables such as days to death, the things that characterize the patients in the sample or in the data. And the third piece that we have here is a sample map, which is mostly for keeping tabs on what patients are associated with what samples. And for the user doesn't really have to work with this sample map other than provide it at the beginning of the object. When we create the object, we provide a sample map if possible, or it will be generated based on what we have in the data. So,
Marcel, you're not sharing.
So those are the three main components of the multi-assay experiment.
Sorry, Marcel, we're not seeing your screen anymore.
Can you guys hear me still?
Yes, but we cannot see your screen.
Because I think my my browser here is frozen for some reason. Yeah, so
I'll
yeah, those are the three main components of the multi-assay experiment class. One contains the data, which is the experiments portion, and the other contains a sample map, which relates patient identifiers to the sample identifiers and the assays. And here the assays are those the data contained in the experiment. So they must have names so that everything can be tracked. Can you click on continue?
Yeah. Okay.
Okay, so the first thing that we want to do is pull up our mini ACC example from contained in the package. And you do that using the data function and mini ACC. And then if you run that, you'll see that it gives you a multi-assay experiment. And in order to access
what did I do? I just went to... should I go... Is there a way to go back?
Yeah, if you click at the top, yeah.
There we go, next topic. Yeah, my bad. I just went to click on the panel and it took me to the next one. Never mind.
Weird. Okay.
I'll stay quiet.
Yeah, once we have this is the how a multi-assay experiment is displayed in your R console. And we can use the experiments function on this mini ACC to have a look at the experiments in the multi-assay experiment. So in line 3, can you type experiments, parentheses, mini ACC?
And yeah, I just ran again, right?
Yeah. Great. So that's one way to obtain the list type of data within the multi-assay experiment. And you can see what assays are in there. So we have RNA-seq, GISTIC data, protein mutations, and microRNA data sets. Now you can click continue.
Did it take me? Okay.
Yeah.
So there was this next message.
Mm-hmm.
Oh, okay. Now we can see the list of experiments. Yep.
Okay, so many of these extractor functions, these functions that pull components out of the multi-assay experiment, are have the same name. So in order to access the call data within the multi-assay experiment, you do call data and then the multi-assay experiment. Exactly. Yeah. Thank you. So you'll see what kind of variables are in our example data set. And this data set was taken from TCGA, and it's a subset of the adrenocortical carcinoma data set. You can click continue.
Yeah. Okay.
So we have some convenience functions to extract data from this call data structure. And we've added a $. So if you do mini ACC $, and the name of a column in the call data, you'll get that variable. So because this is using RStudio and their software in the background, you can see the list of variables in that data set. So you can run that. Nice. Okay. So now we'll go into the assays portion.
There we go. I had to click a couple of times.
Yeah. So assays lets you extract the data as a list, which is slightly different from the experiment list. Our experiment list is our own data class that we created to contain all of the different data sets, but assays should give you a matrix a list of matrices in return, so that you can plug that into other software and analytics tools. Okay, so we'll go into the sample map, just to have a look at what that looks like.
Sample map.
Yeah. So again, if we're trying to get a component from multi-assay experiment, we use the same name as a component, the function with the same name. So yeah, sample map in the ACC. So we tried to make this as easy to use as possible, and we're open to feedback. And so.
Oh yeah, the first line, actually the mini ACC prints this, so the sample is actually the next block.
Yeah.
Just
yeah. So it's a data frame with 3 columns, as you saw in the graphic: assay, primary, and call name, and these correspond to the assay names, the patient identifiers, and TCGA samples in this case. All right.
So maybe on this here, it would be a good time to take there's a question in the chat, which is wondering whether we can have different patients with different data modalities.
Yes. You can have, so not all patients are required to have all the same modalities. So you can have some patients with one data type and not the other. So yeah, that's possible. Okay.
All right, test your knowledge.
So what do we use to extract our experiments? So yeah.
So yeah, it's a shame you can only do yes/no answers for the. I would have submitted this one to the audience. Okay, right. Shall we go? Common mistakes. Do you want to make a point about this?
Yeah. So this is it's I think when we designed this, we wanted to differentiate from what the experiment list class is and what the extractor function is for the experiments. So the experiment list is a class that we make use of in multi-assay experiment, but the experiments is lowercase e. Experiments is the extractor function to obtain that class. So it's easy to get them mixed up. So I added this note here.
Okay.
So continue.
Right, experiment list.
So once we have all of those components, and you can recreate these components based on what we have in our example here. So we use experiments, call data, and sample map. We can add that to our multi-assay experiment function to create a multi-assay experiment. So you can click on the solution button. Yeah, and that will give you an idea of what a multi-assay experiment constructor function call looks like with our example here.
So shall I copy it to the code and run it?
Yeah, you can do that.
For example, if you do that, you should get the object back because we're not saving into any variable.
Yeah.
Okay.
Okay. So that's it for the first portion of the workshop, and feel free to run that on your own or go to our package down website, which I linked in the slides. So now we can open up the cBioPortal tutorial.
So I'll close this one. And so the vignette, you mean?
No, we also have another shiny.
Oh, my bad. Yeah.
Yeah, the vignette technically is an R&D file. So usually call that when we need to.
Same story, run document.
Yeah.
Oh, that's convenient. Nice, reproducible. And you've got your test user right there. Okay, so this is compiling. There we go. Oh, right, I've stopped sharing. So, yeah, I'll start sharing again. The app just opened.
Thank you.
Sorry, it was happening on my screen. I just forgot that it was not happening on everyone else's. Yep, that looks like it.
Yep, thanks. So now that we know what multi-assay experiment does, we can make use of it with cBioPortal data. And we've worked on this package to make use of the prepackaged data that cBioPortal provides, as well as the API endpoints that are available. So let's click on continue here. So in order to see what study identifiers are available through the cBioPortal service, we can use the data function with an argument package. Package equals cBioPortal data.
Oh, the documentation is a bit finicky.
You're missing a C in package.
Oh. Well done. There we go. So that's how. Well, never mind. That's not super helpful. Our message. Here we go.
Okay. Yeah. So we have a data set called studies table, and I could have come up with a more creative name, but so if you run that in the console,
Treat like that, or do we need? Okay.
You'll see what that has inside of it. So we have in the first column the cancer study IDs that are available, and in the last column we have a pack build and an API build variables that tell you what data sets we can import as a multi-assay experiment currently. So let's click continue. So yeah, we can use, I guess we did that already, so maybe click on solution or something. Yeah.
So let's continue as well, right?
Yeah.
I'm just not clear on continue too much because I'm not sure if I can go back. So I'd rather have you tell me explicitly than.
Yeah. Thanks. Okay, so we can get the so say for example we found a study identifier we are interested in. We take that study identifier and feed it into the cBio data pack function, which gives us access to the prepackaged data sets. And these data sets are hosted on an Amazon bucket for the time being. And they're tarball or tar files of the entire data set for a particular study. And yeah, you can run the code. So we automatically provide caching. So when you download this this data set, it will be cached, so you don't have to re-download it every time. And then we take the data, extract it automatically for you, and represent it as a multi-assay experiment, so you can see what kind of data sets are in this ALL data set from St. Jude. Okay. One thing I wanted to note here is that we make use of our ragged experiment data structure, which is a useful structure for representing mutation data. And we use it because some data sets don't have an equal number of measurements across all of your patients. So they could have, what I mean by that is, like, genomic locations are not the same the measured genomic ranges are not the same for every patient. So Ragged Experiment tries to take this data and convert it into a matrix type or matrix-like format for multi-assay experiment to be able to use. Yeah. Continue. Yeah. The other function that we have in cBioPortal data is called cBioPortal data, is the same. So, and this makes use of the API, so it gives you more flexibility to get the data that you're interested in. So first we create a cBio, we use the cBioPortal function, which, that one, and assign that to an object called cBio. And then you can print the cBio object in line 2. Yeah. So in R, we need some kind of object that represents the cBioPortal API so that we're able to query their service. And so that's what the cBioPortal function is doing. It's taking the API protocol and creating an R object so that we can use for all of our queries. So that's the first thing that we do. You can see a summary of what is in that object. It lists all the operations possible, but the user doesn't really have to worry about all of these operations because cBioPortal data manages that for you in the background. So you can go continue, please.
Okay, we just have a question looking RPPA.
Yes. Anna asks, is our PPA data available from TCGA? Is it accessible via cBioPortal? And yes. So we'll go into an example where we can see what data is available. Okay, so now we want to construct our cBioPortal data function call. And so we have the study ID already. And then we need a gene panel ID or a set of genes that we are interested in. And we also want some molecular profile IDs. So these molecular profile IDs is what we call assays in multi-assay experiment, but cBioPortal gives it, they have different names. So this is what cBioPortal annotates these data sets as. So if you click continue, we can get a look at what gene panels are available in the service. So you can
It doesn't remember what cBio is apparently.
Oh yeah.
Okay, so that was cBioPortal. It's not helping with the capitalization. Okay, it's a bit picky about that, blah blah blah, and it should work.
Yeah, thanks. Yeah, so they have a list of gene panels related to studies. So we can use one of these to create our query. If you click on the, I guess the right arrow in the description.
There we go. Yeah.
Yeah, you can see that these are the gene panel IDs that are that we need to use as the input.
All right.
So I think we can click continue, and it will do the same.
We'll do it in the next panel. Okay.
Yeah.
Brilliant.
Oh no, that's okay. Yeah.
So I still have them above if I need to copy paste.
Mm-hmm.
All right. What do we do now?
Okay. So for the molecular profiles, this will give us an overview of what assays are available for each study. So our input for molecular profiles is the first thing is the cBio API object. and then we have the study ID of interest. So in this case, we'll use ACC underscore TCGA.
So, okay, quoted, I suppose, right?
Yeah.
It's a identifier. Okay.
And then we need to include the cBio API object as the first argument.
Oh, as a first. Sorry.
That's okay. Thanks for helping out.
It's all right. I'm just looking if it's offering me. There we go. So the API is the first, and then it's offering me the study ID that is the next one.
Yeah.
Just so that people can follow the arguments. And cBio is not found again. All right.
Yeah.
Well, actually, I've been postponing way too much learning about multi-assay experiments, so here's my chance.
So we get a table of a description of the molecular profiles from the API service, and if you click on the right, there's more description, and I think there's a keep going. Here is the molecular profile ID that we use as input. So to answer your question, like the first one that we see there is the RPPA molecular profile ID. So we'll use that in the coming example. Okay. Okay, so once we have those pieces of information, we can generate our cBioPortal data function call. And to make it a little bit easier, you can just click on the solution here to see, have a runnable example here. Copy the clipboard.
There we go. So we've got the study ID and the gene panel ID in addition, and then a couple of molecular profile IDs.
Yeah.
So people can see the difference. And running the code. Oh, come on! I should actually just put it in my clipboard, that command.
Yeah, I'll update this tutorial to get around that issue. I thought it would remember cBio.
Hang on, what did I put it this time, right? cBioPortal, why isn't it still not happy?
Huh. I think, yeah. So, it might be an issue with the Shiny app, actually.
Let me just try that. If I run the command alone, it's happy. And so now, if I run it with the second part,
weird. Can you try running the function instead of cBio, maybe in there?
Oh, yeah. Okay. Let's.
Yeah, it might be an issue with the Shiny.
It's weird because it was doing it in the previous code block.
Yeah.
But anyway, hacking 101 for everyone listening.
Well, so it works. Awesome. Yeah. So we implemented a caching mechanism that takes your inputs and caches the inputs so that if you rerun this query, it doesn't download data and provides only the data that's cached. So I think that's why the issue happens here, because some of the stuff in Shiny is doing other things. So anyway, so you can see that the output of this function is a multi-assay experiment with the two molecular profiles here. And that's the two interfaces to cBioPortal data that allow you to obtain the data. There's also a little bit more advanced way of using the service. So if you want to run different or select different endpoints to the API, you can use that cBio object and work with that to generate different queries.
That's where it would be.
Yeah, so you don't have to, yeah. So that's pretty much it for my workshop here. If you have any questions, feel free to post them in the feed here.
Okay. Apparently there's some trivia coming up.
Right.
But,
So
right.
maybe we can do the trivia together.
And yeah, people can raise their hands if they want to answer. So,
or put the answers in the chat, the suggested answers.
Yeah.
That, yeah, much better, much faster. So what function provides prepackaged by cBioPortal study data in its entirety? All right, so we've got data, we've got cBio data pack, cBioPortal, and load. Does anyone remember that one?
Oh, we have Felix with the right answer here.
All right, for the sake of, how many questions do we have? 1, 2,
Just
3, and
here.
3 minutes. So I'm gonna send it in there. Yeah.
Nice.
What function can you use to obtain the cBioPortal data as served by the API service? So we've got cBioPortal, cBioPortal data, molecular profiles, and cBio data pack. Again, and in the meantime, I suppose if anyone has questions of their own rather than the trivia, please. We're just filling time, I think, at this point. No one?
Yeah. cBioPortal data, yeah.
Oh, on fire. Oh, it's learning from the context. And what components do we need to use the cBioPortal data function? So there is a potential S, but there's only one answer. Okay, yeah. So the study ID, the gene or gene panel ID, the molecular profile IDs, or all of the above.
Yeah, so for this one, all of the above. And I also wanted to note that if you have sample IDs that you're interested in, say for TCGA, you might have some patient IDs or sample IDs, you can put those in the function as well.
Okay.
Are there any other questions from the participants?
We've got the clapping.
Applauses. I think you can also find Marcel in the conference platform later this week if there are questions that come up, or Levi as well.
Yeah.
All right.
Well,
Very
thanks,
good.
everyone.
Okay, Harry, there is a question. That was an answer.
So we do have Levi in the session.
Yes.
Do we want to say it out loud or?
Okay, so yeah, it's the question whether RPPA data is available from TCGA. It's related to that one.
All right. But yeah, again, our speakers are around, so feel free to arrange maybe a time to meet at the table in the lounge. It tends to be a bit empty, but if you contact the person directly, I mean, I'm sure they'll be happy to arrange a time. And there's plenty of tables in the lounge. And yeah.
Yeah. So with that, I'd like to thank Marcel and Kevin for walking us through this.
Yeah. Thanks a lot, Kevin, and Charlotte, and Levi, and Martin, and everyone who helped me with all of this.
Very nice. Thank you. See you around. And I will end this session.
Thanks.
Thank you.